Yeah, g'day guys and welcome back to my channel. Now most of you will know that I own two CNC lathes, but they're from very different ends of the quality spectrum. And for the longest time I've been meaning to do a video where I turn the same part on both lathes just to demonstrate what the difference actually is. Now this lathe started off as a Sieg 7x12 mini lathe, which I completely overhauled, modified heavily and converted into a CNC machine. In its basic form, weighs about 35 kilos, about 70 pounds. And as you see it here, it's bolted to a big heavy steel plate and then it's on a steel welded frame that I made. So I'm guessing the whole entire thing might weigh maybe, I don't know, 100 kilos, 220 pounds, something like that. So while it's super light, it can swing a part of nearly 180 millimeter diameter, which must be about 7 inches, with a maximum part length of roughly 300 millimeters or a foot between centers. And both lathes are running Linux CNC with the G-Mockupi interface, so in that way they work pretty similar. I did the CNC control of the mini lathe with steppers and it's open loop. Now this is a good example of a machine that's designed to a price. The design engineers would have been given a budget, and that would include things like what's the maximum mass that we can pack 2,000 of these into a shipping container. So lightweight was probably a design criteria, but things like stiffness, reliability and quality would have fallen by the wayside, as it was designed to be able to be sold all over the world, probably for the price of about 4 average car tires. Now the Schaublin 125 CNC was built in the early 1980s and is a good example of a machine that was built up to a standard. That means the design engineers would have been given a maximum deflection budget under worst, heaviest cutting conditions, and everything would have been designed and engineered to ensure that they met or exceeded that stiffness. This lathe's got a 125 millimeter center height, so it can swing about 250 millimeters diameter, with a max work length between centers of about 450 millimeters. Now I don't know what Schaublin charged for this lathe at manufacture, but I'm guessing the price was probably somewhere between a high-end car and a small house. The bed is a massive boxway casting, probably weighing well over 1/4 of a ton on its own. And the whole lathe, including its massive cast iron stand, together weigh about 1.2 tons. Motion control is done through precision ground ball screws, and I've converted it using 3-phase AC servo motors in a closed loop manner. And the machine's much more complicated with pneumatic systems like the back gear control and the collet closer. It's really nice to have a built-in weigh oiler. Right, so what sort of job am I actually going to do on these two lathes? My Clarkson tool grinder is missing a screw, and that's been on the board for quite some time really. Needs to be addressed. Now this being a British machine, I'm pretty sure it's going to be like Whitworth. Probably difficult to find it here in the middle of Europe. You know, rather than waiting to source it, let's try making one. Just check that. Oh, okay, it needs to be longer. Lucky I did check that. Okay, on this side they used a hex bolt. Probably the right length. Okay, looks like that'll work. Okay, so I need the length of this bolt, but I don't think I'll do a hex head. I think I'll do a socket head cap screw. 1/2 inch by 12 teeth. Just check the internet, see what it says about that. I thought so. 1/2 inch by 12 TPI must be Whitworth. So that's going to be a 55-degree flank angle, and needs to be what, about 3.5 inches long, I guess. By the way, I got a bunch of comments about this drawing board. If you want one of these, I'll leave an affiliate link below, because Rotring still makes. Okay, so now let's make 2 of these and see which lathe can make a better job of them. So what am I going to make this out of? Emil in Romania gave me some sticks of this, and he thought they were maybe 4130 or 4340, you know, one of those high strength chromoly steels, so that'd be perfect. It's 20 millimeter stock and I need 19 on the outer diameter. The little 3-jaw chuck, which is standard for this lathe, doesn't have an adequate through hole for 20mm stock, so that's out of it. I could use a 4-jaw, but somewhere along the line I made this ER32 collet chuck, so I think I'll use that. There's so much wobble there. That's not typical for this chuck. I think I'll just check my soft jaws and see if they've got a burr on them. This chuck normally runs pretty true. Yeah, that's better. Whoops. I was trying to be a little more aggressive on the cut there to try and chip, but it still didn't chip. But there was enough pressure to slip in the jaws. So let me reset my Z position and start all over again. From the sparks, I think I was probably also a little bit fast there. Well, that's a pretty nasty stringy steel, but it leaves a lovely surface finish. On the mini lathe there's a bit of an interference pattern. So this should be 1/2 inch. I forgot to make the same measurement on the mini lathe. So now I just need to cut a little undercut for the end of the thread. As you can see, I used a slightly different geometric strategy between each of the two lathes. Now I normally prefer to do my thread cutting with these threading inserts, but they're the wrong angle. But I've only got these for 60-degree threads, metric or American, whereas British Standard Whitworth is of course 55. The other option I have is this cemented carbide, which I'm sure I ground for 60 degrees, but it'll be easy enough to touch that up. $20, $25. Yeah, it must be 27.5, isn't it? Alright, now to get this in front of the wheel, I could either take off the spacer or I could flip this around. I think I'll just do that. I think the wheel needs to come down a lot. I think I'll just bump it up to copy the existing clearance angle. Hey, checking the statistics, I see that both Michael from Germany and also Peter from California have been watching heaps of my videos but haven't subscribed yet. So come on guys, step up, we're on to you. Well, it doesn't take much to touch up that edge. I'll just give it a couple of licks on the nose with the diamond file, just to take off any brittleness of that sharp edge. Right, I'm going to need to set this tool to center height. The way I'm currently doing it, I should probably make up a special tool for this, but I just do it with the whatever this height marking tool thing is. That's not the right way. I think I know what I did wrong. I 1.3. Positive values of I are internal threads, so I needed a negative on that. To measure the thread, I'll just use a 3-wire method, and because I don't really care what the exact size is as much as just a comparison size, I'll just do it with welding wire. Looks like it's about 14.25. So let's try the cut thread. Alright, that looks okay. Let's see how this now looks. Okay, actually went slightly under that time, probably a 1/10 under. Be a bit looser screw. With the thread now cut, I can extend the stock and cut the shaft. Whoopsie daisy, that's too much pneumatic pressure on the tailstock. I'm going to have to set it all up again now. Just throw a mark on it so I can see if it starts sliding. Uh-oh, they're both slipping this time. Okay, so I've dropped the pressure on my compressor. We're down to about 3 bar now. So this is the operation which kind of separates this lathe from the mini lathe most clearly. Right, now I'm just not enough of a masochist to even try parting off this kind of tough steel on the mini lathe. Since I've just got the bandsaw gearbox working again, let's just use the bandsaw. Just grip it in a vice to stop the thing from spinning on me. Whoops, guess I was pushing too hard. I mentioned in my last video that I was having a few tracking problems. I didn't actually get around to taking a good look at it. Got a lot of good advice of how to address the tracking. I mean, it's pretty close to being correct. Still need to have a bit of a play with it. I was told that I probably had too little blade tension. Well, the Schaublin's got a button to engage the back gear. On this lathe, I put a high-low gear selector here on the back. All things considering, that's not a bad job for a little lathe to do a 10mm hole like that. Well, this is the last operation on the mini lathe because putting the hex in is well beyond the stiffness capabilities of this little lathe. So this is the bit which the mini lathe definitely can't do. Using my lovely Made in Malta rotary broach to put the hex in. Might have pre-drilled my hole just a wee bit big there. So after all that, how did they work out? It's easier to hold tolerances with a Schaublin, of course. There should be 1/2 inch. I'm 4/100ths under there and 3 over there. You know, I didn't put any real effort into holding tolerances because they're only pretty simple bolts, but I went quite undersize on the shaft here. The drill size I chose for clearance for the hex was definitely too large, so there's not a lot of driving flank there, but luckily these bolts are only going into cast iron, so there should be enough driving torque to make them work. The Schaublin bolt threads in nicely, as does the one from the Mini-lathe, although that's maybe a little bit tighter. So it's the Schaublin bolt that's going to get installed. Let me just degrease it. And at least blew up the head to make it match the rest of the machine better. By the way, this is the bluing compound I've been using for years. This bottle's lasted me probably 20 years, so I don't do it that often, but when I do, this is what I use. If you're interested, in the States, I'll leave a link down below. I don't know if you can get it in Europe. Well, after a bit of dicking around, I put the hex bolt back here. And putting my new homemade bolt on the other side. Right, well that's that done. And in fact, that's the only job I had open on my klaxon at this stage. So I can make some space for something else. Now obviously, a direct choice between the Schaublin and a Mini-lathe is silly. No one would ever choose the Mini-lathe. But really, that's not the choice that people actually make. The real choice is more between having no lathe or having the Mini-lathe. And in my mind, that's also a no-brainer. The Mini-lathe is still capable of quite impressively good work if you take the time to work around its limitations. So what should I do with the Mini-lathe built screw? It's not like I'm ever going to use a 3.5 inch by half British Standard Whitworth for anything. I guess it'll get recycled for something. This video went up later than I normally put them up because I was watching the last races of the MotoGP season. Awesome. Thanks for watching.